So looking at number 8, with calculator for sure. Start by finding the area. So graph both of those in the calculator, figure out what the bounds are. There will probably be some weird decimals when you do intersections, storing for A and B, all of that stuff. So try A, and then we'll come back and look at it. Won't be much recording. Top minus bottom, find their intersections. I would store them as A and B. A few of you didn't keep enough decimals, and so you missed the final answer. A few of you kept barely enough and got the right answer. But the best method is to store A and B, and then use A and B in the calculator. That way you get the most accurate answer possible. It does need to be accurate to 3 decimals, though. So 1.949. Okay, part B. So generally speaking, we're 1 for 1 here. Part B, if R is the base of a solid, so that's R, with square cross sections. It doesn't get much easier than that if you're going cross sections. S squared. Perpendicular to the x-axis. What is the volume of the solid? I'm just going to press pause. Again, lots of right answers out there. The square is top minus bottom squared. Top minus bottom is y1 minus y2. It's still the same A and B. So that one was a pretty quick one. Let's move on to part C. If the base of a solid with square cross sections, all right, shh. Thank you. Perpendicular to the y-axis. Now we're slicing the other way. I should probably redraw the picture, or else I'm going to get messed up here. And actually, A and B aren't really going to matter as much now, because I don't need A and B if I'm slicing with y. I need those y values from C to D. So I'll need to go back and find those intersections, because I need the y values of those intersections. So I need to find C and D, probably store them so that I can get as accurate as answer as possible. Still a square, so right minus left side squared. But that means the right one is y equals x minus 3, except it's now dy, so I have to change that around. Let's do it down here. So y equals x minus 3, which means x equals y plus 3. So the right one is y plus 3. The left one, let's see, what was that? Natural log of x minus 1. That's going to take a little work. E to the y equals x minus 1. So x equals e to the y plus 1. So there's my s, or my r minus l. That's kind of ugly. So this one's worse, because I got to figure out C and D. That's not too hard. That's just calculator work. A little bit of algebra work. And then I can't do y1 minus y2. I'm going to have to type this stuff in. So yeah, this is going to be a little bit uglier. Let me find those intersections. So D is 1.146. I can't just exit out and store, because it doesn't remember the y value. So I need to write down 1.146, 1932. That's probably overkill, but better safe than sorry. I don't know that I need to. I don't know. I'm going to store it as C, because that's what I said I'd do. Whoops, no, that one's D. But I could have just written it down when I did the integral, when I did Math 9. And a bunch of you did that. You just wrote out the whole number, and that's fine. Now for the other intersection. First curve, second curve. Let's go back and get this intersection, but I need the y value of the intersection. Negative 1.841406. So Math 9. I'm going to combination these just to be confusing. 1.841406 up to D. So you can mismatch if you like, right? So most people don't mismatch. Most people either save them both or write them both out. But there's nothing wrong with, the calculator knows what D is. I'm just going to type in what C is. Open parentheses. I've got to square all of this. X plus 3 minus parentheses e to the x plus 1, close parentheses, squared dx, and there's my answer, which is the same as the other one, which is weird. I wonder if it's the same because as a square, it wouldn't matter which way you go with the squares. That's my guess. But that is a little bit strange that you get the same answer. Okay, so today's assignment is finish worksheet 1. However much of it you haven't done, do 1 through 9, and we'll answer some of those questions tomorrow.